DC motor is convert electric energy into the mechanical energy. There are two forces, one upward and another downward. The torque rotates coil until the normal position. At the normal position, the two forces are equal in magnitude and opposite in the direction. So the torque must be equal 0. But coil still rotates due to inertia, which pushes the coil to second half cycle. The direction of force is the same, so the torque rotates anti-clockwise. So it backs the coil to the normal position without complete its cycle. Why coil doesn't move as a continuous cycle? Due to reversing the direction of torque that happen after half cycle. The solution, reversing the force direction by reversing the current direction, and we can do this by using commutator. This figure shows how DC motor work in the first half cycle. The current flow in the external circuit and enter the commutator 1, then flow in the direction like this, and then enter the commutator 2 and exit in the external circuit. So the direction from A to B to C to D. In a second half cycle, the commutator is reversed. So the current move as in the first half cycle, but inside the coil it was reversed as the direction it become from D to C to B to A. So the direction of a first half cycle is reversed to the direction of the second half cycle, which prevents the torque from backwards the coil into the normal position without continuous its cycle. Induced EMF according to Lenz's law oppose the cause. In this case, the cause is rotation which comes from the battery. As a result, induced EMF opposes the battery, so it's backward EMF. We can calculate the current from the EMF of battery minus the EMF backward divided by the resistance. The uniformity of coil rotation means the rotation with uniform speed. As we know, the torque is increased, the speed of rotation increase. When the speed of rotation increase, EMF back increase, so the current decrease, so the torque decrease. And when the torque decrease, the speed of rotation decrease, and then EMF back forward decrease, so the current increase, so the torque increase, and this is so on until the speed of rotation become uniform. Problem 1. Motor contains coil with total resistance of 10 ohm and it's supplied by volt of 120 volt. When motor is running at its maximum speed, back EMF is 70 volt. First, find the current in the coil at the instant the motor is turned on. Second, find the current in the coil when the motor has reached the maximum speed. We divided the paper to parts. The current at instant motor means that the current is at maximum and no EMF backward is generated until. So we calculate the current by a general rule, which is EMF of battery divided by the resistance. The EMF of battery is 120 volt over 10 ohm, which is equal 12 ampere. When we find the current in the coil when motor has reached the maximum speed, this means that EMF backward is generated. So we calculate the current by this equation, which is EMF of battery minus EMF backward over the resistance, which is equal 120 minus 70 over 10, which is equal 5 ampere.